At this very moment, a war is being fought inside your body. Not metaphorically, not occasionally, constantly, millions of microscopic invaders are trying to enter through your lungs, your mouth, your skin, and your digestive tract. Bacteria, viruses, fungi, parasites, and countless foreign particles. Yet most of the time, you never notice, because hidden beneath the surface, an army of extraordinary complexity is working without rest. Detecting threats, making decisions, remembering enemies, launching attacks, and somehow accomplishing all of this without destroying the very body it is meant to protect. Which raises one of the greatest mysteries in biology. How does the immune system distinguish what belongs to you from what doesn't? How can it wage a continuous war against microscopic invaders while avoiding civil war against its own tissues? Because when that distinction fails, the consequences can be devastating. And the answer reveals one of the most sophisticated defense systems ever produced by evolution. Right now, trillions of cells throughout your body are cooperating in ways that resemble a vast intelligence network. No central commander exists. No single organ controls everything. Instead, billions of individual cells communicate constantly through chemical messages and direct contact. Together, they form the immune system, a distributed defense network that protects every organ and every tissue. But not all immune defenses are the same. The first line of protection is ancient, far older than humans, far older than mammals. Even simple organisms possess versions of it. This is innate immunity, your skin, your mucous membranes, the acidic environment of the stomach, protective enzymes, antimicrobial molecules. All form barriers that prevent countless invaders from gaining access. And when those barriers are breached, specialized cells take over. Macrophages, neutrophils, dendritic cells, natural killer cells, these are the rapid responders. They do not ask questions. They do not analyze identities. They attack. Macrophages engulf intruders. Neutrophils release toxic compounds. Natural killer cells destroy infected cells. Inflammation recruits reinforcements. Blood vessels become more permeable. Chemical alarms spread throughout the surrounding tissues. Within minutes, a coordinated response begins. But innate immunity has limitations. It reacts quickly, yet it lacks memory. For that, evolution developed something extraordinary: adaptive immunity. One of the most remarkable biological innovations ever created. Unlike innate defenses, adaptive immunity learns and remembers. At the center of this system are lymphocytes, B cells, and T cells. Each one carries molecular receptors capable of recognizing incredibly specific targets. Targets so precise that a single virus may activate only a tiny fraction of the billions of lymphocytes circulating through your body. But where do these cells learn to distinguish friend from foe? Part of the answer lies in an organ that gradually shrinks as we age: the thymus. Located behind the sternum, the thymus acts as a training academy for T cells. Here, immature lymphocytes undergo a brutal process of selection. Those incapable of recognizing foreign threats are eliminated, but those that react too strongly against the body's own tissues are also destroyed. Only a small fraction survive. Cells capable of defending the body without turning against it. This process of self-recognition is one of the greatest challenges faced by the immune system, because every second it must answer a fundamental question: is this me or not? Most of the time, the answer is astonishingly accurate. But when mistakes occur, autoimmune diseases can emerge. Conditions in which the body begins attacking itself. A tragic example of biological friendly fire. Meanwhile, throughout the body, another network silently coordinates immune activity: the lymphatic system. A vast system of vessels and lymph nodes connecting tissues to immune surveillance centers. Lymph nodes are not passive filters. They are command centers. Within them, immune cells exchange information, present fragments of pathogens, activate reinforcements, and organize increasingly sophisticated responses. When you develop swollen lymph nodes during an infection, you are witnessing these microscopic headquarters operating at full capacity. Dendritic cells arriving from infected tissues carry molecular evidence of invasion. Fragments of viruses, pieces of bacteria, molecular fingerprints. These are presented to T cells, and if the threat is recognized, an extraordinary transformation begins. Helper T cells coordinate the response. Cytotoxic T cells become assassins, seeking out infected cells and eliminating them with remarkable precision. Meanwhile, B lymphocytes begin producing antibodies, millions upon millions of identical proteins designed to bind a specific target. Antibodies can neutralize viruses, mark bacteria for destruction, activate additional defense mechanisms, and amplify the entire immune response. Yet perhaps the most extraordinary feature of adaptive immunity is memory. After an infection is defeated, most activated cells disappear, but some remain. Memory cells, silent sentinels that may survive for years or even decades. Waiting, watching, ready. If the same enemy returns, the response is faster, stronger, and often so effective that the infection is stopped before symptoms even appear. This is the foundation of immunological memory, and the reason vaccines work. Vaccination allows the immune system to rehearse, to learn, to build memory without suffering the full consequences of disease. A biological form of experience, one that saves millions of lives every year. But immunity is not simply about destruction. Restraint is equally important, because an overactive immune system can become dangerous. Allergies represent exaggerated responses against harmless substances. Autoimmune diseases turn defense mechanisms against the body's own tissues, and excessive inflammation can damage organs as severely as the infections themselves. For this reason, specialized regulatory cells continuously suppress unnecessary reactions, maintaining balance, preventing chaos, avoiding civil war. And the immune system is never truly isolated. It communicates constantly with the nervous system, with the endocrine system, with the microbiota living inside the intestine. Hormones influence immune cells. Stress alters inflammatory responses. Sleep affects memory formation. Nutrition shapes defense mechanisms. Every physiological system participates in this hidden network. Even aging changes the battlefield. As the thymus shrinks and immune efficiency declines, infections become harder to control. Cancer cells become more difficult to detect, and the delicate balance between defense and tolerance becomes increasingly fragile. Yet, despite all these challenges, the immune system performs miracles every day. Every breath you take introduces foreign particles. Every meal contains unfamiliar molecules. Every cut in the skin creates an opportunity for invasion. And still, most infections never become life-threatening. Most dangerous cells are eliminated before you ever know they existed. Most battles end in silence, unnoticed, uncelebrated. Because perhaps the greatest triumph of the immune system is not the wars we remember, but the countless wars we never realize were fought. The viruses destroyed before they multiplied. The cancerous cells eliminated before they formed tumors. The bacteria engulfed before they caused disease. Hidden beneath your awareness, trillions of cells are making decisions, identifying threats, remembering enemies, distinguishing self from stranger, balancing aggression with restraint, protecting you from a world you cannot see. And perhaps one of the most astonishing facts about being alive is this. Inside your body exists an army with no general, a memory with no brain, and a war that never ends. A war fought in silence, second after second, for as long as you live.